imaginary numbers. So imaginary numbers. So the numbers of the form z is equal to x plus iy. So the numbers of the form x plus iy, these are called complex numbers. So in this complex number, we can see that we have two parts, the real part and imaginary. So the real part, we write real of z, which means this is the real part. And imaginary of z is y. See, imaginary part means the part is the part which is coming with I. Or in other words, we can say the coefficient of I. The part or the number coming with I, that is the imaginary part. That's the imaginary part. So here, x is the real part and y is the imaginary part. Again, we learned if x is 0, if this x is 0, then this number is a pure imaginary number. There's no real part in it, there's a pure imaginary number. Whereas if y is 0, it's a real number. Y is 0, it's a real number. X is 0, it is pure imaginary. Generally, all complex numbers are imaginary numbers. If x and y are non-zeros, naturally it's an imaginary number, which consists of this. This is a complex number. Then I here I stands for root of -1. I is nothing, it is root of -1. So I is root of -1. So we know the value of I is root of -1. Again, we learn how to evaluate the higher powers of I square. I square is -1, the square root of -1. Again, I cube. I cube is I square into I. This I square is -1, so minus I. It is minus I. Again, I raised to 4 will be I square, the whole square is 1. Now, these are the 4 values. For all powers of I, these are the 4 values. This keeps on repeating. It forms a cycle. It keeps on repeating. That means, again, I raised to 5. I raised to 5 is this one. I raised to 6 is this one. I raised to 7 is this one. I raised to 8. That means it keeps on repeating. Again, next cycle goes to I raised to 9, I raised to 10, I raised to 11, I raised to 12. So see that I raised to 12, the value of I raised to 12 is 1 only. Or all multiples of 4, it will be 1. Reason I raised to 4 is 1. Again, to evaluate higher powers, instead of writing all this in sequence, what we do? We write it in terms of I square. For example, if it's an even number, if you are getting I raised to 52, we write as I square the whole raised to 26. The value of I square, we know I square is -1. So -1 raised to 26 will be +1. So to evaluate any higher power of I, we write it in terms of I square. So even number, all even number, we can write it as I square raised to something. Whereas if it is an odd number, I raised to 45, we write as I, then I raised to 44. This is what we get even again. So this I, we keep it separate. This I raised to 44 again, write it as I square, the whole raised to something. Then the value of I square can be written. So this also we discussed. This is the complex number and the value of I. And we know how to evaluate higher powers of I. Then we discussed complex conjugate. Complex conjugate means two complex numbers which differ in the sign of their imaginary part. That means if z is x plus iy, then the conjugate of it we denote it by z bar. Z bar is nothing, it is x minus iy. See this difference between these two complex conjugates. Difference between these two complex conjugates is that differ in the sign of their imaginary part. See, imaginary part is here positive, see, imaginary part is negative. Then another commonly seen mistake, if we get z is equal to minus a minus id, its conjugate, the conjugate of this one, it will not be a plus IV. This real part remains as it is, only change in the sign of imaginary part. The only change is change in the sign of the imaginary part. So real part remains as it is. So real part remains. This is the complex conjugate. Then modulus. Modulus of the see, if z is x plus I y. If z is x plus I y, then we write this as modulus z. Modulus z is root of x square plus y square. This is modulus z. That also we discussed modulus z. Then z inverse. The multiplicative inverse is z bar by modulus z square. This also we discussed. And I think you got a question to your test as well. Z bar and Z inverse. So inverse, multiplicative inverse is Z bar by modulus of Z square. Z bar means Z bar stand for the conjugate of the complex. So the conjugate divided by its modulus. Square of modulus will give inverse. So these many things we learned before your test in the previous class. Today we will learn something interesting called the polar form and argand plane. The polar form and argand plane for this complex. Plane. You know what the plane is in maths, not that plane what you're seeing up. Not plane means plane surface. Plane in lower classes you learn Cartesian plane. Cartesian plane means, yes, this one somebody polar form. Somebody you can write. Just write the heading, then don't write anything. I will give notes at last. I will give notes at last. First see this one. So Cartesian plane. Cartesian plane means you learn in lower classes. We have x dash, y. This is called the Cartesian plane, where x and y axes are marked. And by the use of this x and y axis, the use of it, why do we need these two perpendicular axes? The reason to locate any point. And we know that if this point P, if the coordinate is 3, the coordinates, you learn in lower classes, the coordinates are 3. Here, 3 is called the x coordinate, 2 is the y coordinate that you learned in lower classes. Again, the meaning of x coordinate, what does this mean? X coordinate 3 means what's the meaning of it? Actually, x coordinate is the distance of that point from the y-axis. See that x coordinate is the distance of that point from the y-axis. Distance of point from y-axis, naturally, its measurement, it is measured on the x-axis. See this point. This is the y-axis. Distance. That distance is measured here. That we mark here, 1, 2, 3. This means, so this x coordinate denotes the measurement on the x-axis. Measurement on the x-axis means actually it is a distance from the y-axis. So distance of this point measured from the y-axis. Distance from the y-axis which is measured on the x-axis. Its measurement is on the x-axis. Similarly, y coordinate 2 means this is 2. This is 2 units. So this point 3, 2. This point P is marked in the Cartesian plane. So in the Cartesian plane, the coordinates, and what is the use of this coordinates? See, for example, this coordinate 3, 2. The use of this one. See, if I am asking you to locate a point in this plane, I am taking all of, I am giving you a sheet of a graph paper, or I am giving you a graph paper. And if I am calling a point, if I am asking you, mark the point 15, 10 or 15 centimeter, 10 centimeter. then definitely you will measure 50. If I'm asking to draw 15, 10, you will take 15 centimeter from x-axis, that is here. Then 15, 10 axis. Then from here you will measure 10 centimeter up. So we reach. So this is the point. This is 15, 10. So this means if I'm giving the coordinates of a point, you can locate the point exactly. We get the position of that point. We get the position of that point exactly, is it? So position, we got the position. So generally, if this point is x, y, or if the coordinates are given, this is x, this is y. So if the coordinates of a point is given, we can determine that point uniquely. Uniquely means, for example, 3, 2, the point 3, 2. 3, 2 means it is this point. And no other point will be 3, 2. 3, 2 means only one point we have in the plane. The point 3, 2 is only one point and that point is here. Whereas 2, 3 means it's a different point. 2, 3 is a different point. 3, 2 means only this point. So to identify or to locate a point uniquely, if we get the two coordinates, x coordinate and y coordinate, we can get that, or we can locate that point exactly. Similarly, can we locate this point without getting this x and y coordinate in any other way? Yes. One more way is there. That way, see what I do is I will measure this one. This length is coming as 19 centimeter. 19 centimeter. So this point P is 19 centimeter. P is 19 centimeter from the origin. 19 centimeter from the origin. So if I am saying, see previously I said, locate the point 15 centimeter, 10 centimeter, or 15, 10. If I am saying 15, 10 means exactly you can measure 15 centimeter along x-axis, 10 centimeter along y-axis, you got exactly the point. Whereas now if I am saying P is 19 centimeter away from the origin, if I am saying 19 centimeter away from the origin, can we get that point exactly? No, 19 centimeter means it can be anywhere on the sun. Everything is 19. Any point on the sun. If you take any point on the sun, you can see that all those points are 19 centimeters, 19 centimeters, 19 centimeters. All points are 19 centimeters away from the center. That means with only this measurement, we cannot locate it exactly. We need one more thing. What is that? The angle. See, if I am saying 19 centimeter and this angle is 60 degrees. Definitely, if I am saying this two information, this two data means length of this one and this angle, then definitely we can locate that point exactly. In the previous case, in the Cartesian form, how did we locate the position? By taking those two coordinates. There also we need two information. One is the x coordinate, and second one is the y coordinate. So if you are getting two information, the point A 15, 10. You can exactly locate the point because 15 centimeter takes 15 centimeter here, takes 10 centimeter here, we reach the point B. Similarly, if I am saying 90 and 60 degrees, in this way also we can exactly get the point. How to get the point? First we can take 60 degrees. Using your protractor, you can measure 60 degrees. Then take 19 centimeter along and mark this point B. Now we got it. This is point B. So here, instead of coordinates, x and y coordinates, I gave another two information. What was it? This length and the angle with which it makes the x-axis. So representation of a point in this way. This is called the polar form. So in polar form, instead of x and y coordinates, we get this length of OP and this angle, So here, this polar form. Similarly, this complex number, if a complex number x plus iy, z is equal to x plus iy, then this point x this point B. This is A. This is X and Y. So this complex number, if a complex number is marked on a plane, those planes are called Argand plane. The other one is Cartesian plane. In Cartesian plane, we mark real numbers. Whereas the plane with complex numbers in it, they are called Argand plane. In Argand plane also, for representing this point, for denoting the point, we have the coordinates or we can use the polar form. Polar form means, see, if this is called modulus of R, is it? This is x squared plus using Pythagoras theorem. Using Pythagoras theorem, this is x squared plus y squared, is it? Because if this is x, this is y. Using Pythagoras theorem, length of OP is root of x squared plus y squared. So if a complex number is given as x plus iy, we can find the modulus. That is root of x squared plus y squared. Then this theta, this is theta. Now see, from this figure, what is cos theta? From this figure, we know that cos theta is adjacent side by r, modulus of z, where r is modulus of r is modulus of z, which is root of x squared plus y squared. So from this figure, cos theta is x by r. From this, we can write x is equal to r cos theta. Similarly, sin theta. Sin theta is y by r. From that, we can write y is equal to r sin theta. Now, this complex number x plus iy. X is r cos theta and plus I into r sin theta. If you are taking r common, cos theta plus I sin theta. Here, r into cos theta plus I sin theta. So the complex number, when expressed in the form r into cos theta plus I sin theta, that is called the polar form. So in polar form, where r stands for modulus of this one, and here theta is called, this theta is called the argument or sometimes we call it as amplitude. The argument or amplitude of this complex number. So if we know these two measurements, that means the modulus of a complex number and theta. Argument means it is the angle made by this line OP with the x-axis, that too measured on the positive direction. Again, we know the positive direction, negative direction. Positive direction means from x-axis anti-clockwise. Negative means clockwise. So this in this way, in anti-clockwise direction, we are measuring it. That is theta, and theta is called the argument or amplitude. We write argument Z. So write these things: polar form and Argand plane. Right, somebody? Polar form and Argand plane. Right. The point P x y. The point P x y. The point P x y can be uniquely the point P x y can be uniquely located in the Cartesian plane. In the Cartesian plane, the point P x y can be uniquely located in the Cartesian plane if we know the values of x and y coordinates. If we know the values of x and y coordinates. Next slide. A plane with complex numbers in it. A plane with complex numbers in it is the Argand plane. The Argand plane. Next line. The x and y axis in the Argand plane. The x and y axis in the Argand plane are called real and imaginary axes respectively. The x and y axis in the Argand plane are called real and imaginary axes respectively. Usually in Cartesian plane, we draw horizontal line, we consider horizontal line as x-axis, vertical line as y-axis. Same thing, here also we mark it as x and y. But instead of calling it as x and y axis, if it is complex number, we call it as real axis and imaginary axis. That's the difference. By naming it, we name it. The idea and concept, everything is now. Then draw this figure. This is R is equal to what? Draw this figure. Draw this figure. Let me take the attendance also. All right. Let z is equal to x plus I1. And let z is equal to x plus I1. Then R is equal to modulus of z is equal to root of x squared plus y squared. R is equal to modulus of z root of x squared plus y squared. Then write from figure cos theta. From figure cos theta is equal to x by r. Cos theta is equal to x by r. Therefore x is equal to r cos theta. X is equal to r cos theta. Next, sin theta is equal to y by r. and y is equal to r sine theta. Z x plus iy. Z is equal to x plus iy is equal to r into cos theta plus I sine theta. This is, next slide, this is the polar form. This is the polar form of the complex number x plus iy. This is the polar form of the complex number x plus iy. This is the polar form of complex number x plus iy. Next line, here r is the modulus. Here r is the modulus and theta is the argument or amplitude. Argument or amplitude. Theta is the argument or amplitude. Now, again, listen. See, now, like in trigonometric equations, we have the principal value. See, in trigonometric equations, what we did is, now we say everything in gradient measurably. In trigonometric equations, the principal solution means the solution coming from 0 to 360. That means measure the principal. See, in this full measure, the angle coming from, if you are taking the angle from 0 to 360, then everything, if the terminal ray of the angle falls in whichever quadrant, it is coming, it is measured, right? See, for example, if you are taking, if this is terminal ray, this is terminal ray, this is 30 degrees. We learned it in trigonometric equation, 30 degrees in quadrant 3. In quadrant 3, we learned this one. This was alpha is theta is equal to alpha. This was pi minus alpha. This is pi plus alpha. 2 pi minus alpha. This is for trigonometric equations. So for example, here we are getting 30 degrees. Again, how will you find alpha? By removing that negative values, taking the numerical value. First, we find alpha in quadrant 1. Then we will see which quadrant it lies. If it's in quadrant 3, 30 degrees means we take pi plus alpha. That means pi is 180. So 180 plus alpha means 210. This measurement, we measure in this way. This is 210 degrees. Is it? 210 degrees. This is in trigonometric equations we did. Whereas here in complex number, instead of taking it in this way, from 0 to 360, what we take is, we take it from minus pi to pi. Minus pi less than or equal. This means, this is 0. Minus pi means minus 180. How, this is 0. How will you start from minus 180? Minus means it goes in negative direction. Okay, so we start measuring from here. Here, then comes, see in this way also, all 4 quadrants are covered. In trigonometric equation, we started from 0 to a full circle. Starting from 0, taking the full circle, we covered all 4 quadrants. In complex numbers, instead of starting from 0, we start from minus 180. Minus 180 to 180, again we are covering all 4 quadrants. There also, we have the full circle. In trigonometry, 0, it is full circle, whereas In complex numbers, from minus 180 full circle. Again, all four quadrants are covered. So here, minus 180 full circle. So in this case, what we do is, this is pi by 2, pi. Okay, each of this one. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. So in complex numbers, we take argument theta as alpha. This one, our theta will be pi minus alpha, same as. So first two, it is same as trigonometric equations. Third quadrant, instead of pi plus alpha, we take minus pi plus alpha. Minus pi plus alpha. Alpha, pi minus alpha, minus pi plus alpha. This will be minus alpha. See, for example, this one. This is 30. If this is 30, in complex numbers, we take it as minus pi plus alpha. Minus pi plus alpha means minus 180 plus 30, which is minus 150. See, that means instead of measuring from 0 to 210, we measure this angle in clockwise. Definitely, this is minus 150 degrees. See that the position of the terminal ray remains the same. The position of the terminal remains the same. Position of terminal ray. In the case of trigonometric equations, we measured this angle clockwise direction, so it became 210. Whereas in the case of complex numbers, this one we measured in clockwise direction, negative. In short, for complex numbers, if we get the position of the terminal ray or the angle, we call this the angle in quadrant 3 or 4. If the angle is in quadrant 3 or 4, we take negative direction or we measure it clockwise. Whereas in trigonometric equation, always we measure in positive direction. In complex numbers, if we get the angle in third and fourth quadrant, we take it in clockwise negative direction. Whereas first and second quadrant, same thing as trigonometric equations. So here, this is the only thing to remember. It is slightly different from complex trigonometric equations. Trigonometric equations, this we discussed it, we learned it. In complex numbers, this one. So write us next note. Next note, next line. Defined the principal value of the argument. Define the principal value of the argument. Defines the principal value of the argument, that is minus 5 less than theta less than or equal to 5. Minus 5 less than theta less than or equal to 5. And use, draw this, alpha, pi minus alpha, minus plus alpha, minus alpha. And use this table. And use this one. Line. Defines principal value. Defines principal value. First, find alpha in quadrant 1. First, find alpha in quadrant 1. In bracket, how do you take quadrant 1? Alpha in quadrant 1. In bracket, right? By taking only the positive value. Because we learned in trigonometric equation also, by finding alpha in quadrant 1, we take only the positive, whether it is given value is positive or negative, we take that numerical value. Numerical positive value, we find the angle in quadrant 1. Find alpha in quadrant 1 by taking positive value. Next line. Then to find the quadrant, in which argument principal value lies. To find the quadrant in which the principal value lies, check the sign of x and y. Check the sign of x and y, or the sign of sine theta and cos theta. The sign of sine theta and cos theta. To find the quadrant in which the principal value lies, check the sign of x and y, or sign of sine theta and cos theta. Okay, now while doing the question, I will make it clear. Write this question, exercise 5.2. The first one, find the modulus and argument. First question, z is equal to minus 1 minus I root 3. Listen here. See, so we got z is x plus iy. Instead of x plus iy, we got minus 1 minus I root 3. If x plus iy is minus 1 minus I root 3, we can write the value of x and y very easily. What is x? X is the real part, minus 1, and y is the imaginary part, minus root 3. Is it? X is minus 1, y is minus root 3. Because all complex number, x plus iy, real part, imaginary part. Real part is minus 1, imaginary part y means the coefficient of I is minus 1. Then we can find R. R stands for modulus of z, which is by the formula x square plus y square. We learned it. X square plus y square. This is root of minus 1 whole square plus minus root 3 whole square, which is root of 1 plus 3 root 4. So R is equal to root 4 is 2. See, it is positive square root. Root 4 is not plus or minus 2. It is 2 only, positive square root. So R is 2. So if any complex number is given, you know how to find, how to write x and y and modulus. It's very easy. X is the real part, y is the imaginary part, and modulus R is root of x square plus y square. Again, we learned sine theta, cos theta. Cos theta is x by r. We wrote in the beginning from figure cos theta is x. So remember this, cos theta is x by r. Cos theta is x by r. From this, x is equal to, okay, cos theta is x by r. That is cos theta. No, before, wait, don't wait. Insert this one. We got it. Now, we will write the polar form. See, x plus iy written r into cos theta, because we are not using figure. Instead of using figure, we can write from this one. X plus iy is r into cos theta plus I sin theta. That is called the polar form. From this polar form, we can write the value of x and y. From this, what is x? X is r cos theta. Now put the value of x and r. What is x value? X value is minus 1. R is 2 cos theta. From this, cos theta is minus 1 by 2. We got the value of cos theta. Similarly, equating y is equal to r sine theta. The value of y is minus root 3 is 2 sine theta. Sine theta is minus root 3 by 2. Do it here. We found cos theta and sine theta. Here, if a complex number x plus iy is given, whatever it may be, if x plus iy is given, we know how to write the real part and imaginary part. That means we know the value of x and y. Once the x and y is written, first thing is finding r. R is root of x squared plus y squared. We got the value of r. It's easy. R is root of x plus y squared. After finding out, we wrote the polar form. Polar form is x plus iy is equal to r into cos theta plus I sin theta. Polar form. If you are equating x coordinate x and y, equating x and y means if you are equating the real part and imaginary parts of these two complex numbers, the real part is x here. Here, real part is r cos theta. From that, we found the value of cos theta. Again, imaginary part, we got the value of sin theta. Now, to find alpha, what we do is we take either sin theta or cos theta, one of it. No need of taking both. So we can take cos theta. Now, in quadrant 1, we take cos alpha instead of theta. In quadrant 1, the angle in quadrant 1 is alpha. What specialty of the value of cos alpha? Always we take the positive value only 1 by 2. See, in quadrant 1, always this is what we wrote in bracket. Same thing we did in trigonometric equations also. Do you remember it? In equations also we did the same thing. In quadrant 1 means remove that numerical value. Only the numerical value has to be taken. Taking positive cos alpha is 1 by 2. Cos of which angle is 1 by 2? We know that cos 60. Now don't write here 60. We use only radian measure. We write cos pi by 3 is 1 by 2. Therefore, alpha is pi by 3. We got alpha as pi by 3. Now to find the principal value, see the last sentence what we wrote in this note. After finding alpha, by checking the sign of x and y, checking the sign of x and y. See here, x, y. What is x? Sign x is negative, y is negative. And this one we know. In quadrant 1, both are positive. You learned in our classes. Class 9, you learned it. Not class 9, lower classes you learned. In quadrant 1, both coordinates are positive and positive. What about quadrant 2? This x is negative, y is positive. See the boundaries. Boundaries of quadrant 1, positive x coordinate, positive y coordinate. Boundaries of quadrant 2, negative x coordinate, positive y coordinate. Boundaries of quadrant 3, negative x coordinate and negative y coordinate. Boundaries of quadrant 4, positive x coordinate, negative. This you learned in lower classes. So by seeing the sign, xy is negative, negative. Negative means in quadrant 3. So xy is both are negative means in quadrant 3. In quadrant 3, so therefore argument z. In quadrant 3, we learned quadrant 3 is minus pi plus alpha. In quadrant 3, minus pi plus alpha. If it was in quadrant 2, pi minus alpha. In quadrant 3, minus pi plus alpha, which is minus pi plus pi by 3, which is minus 2 pi by 3. So argument is minus 2 pi by 3. Textbook question is to find only modulus and argument. So therefore, modulus z is 2, argument z is minus 2 pi by 3. So our minus what is it? Minus 1 minus root 3 is r into cos theta plus I sin theta can become 2 into cos minus 2 pi by 3 I sin 2 pi by 3. This is called the polar form. The polar form of this complex number is 2 into cos minus 2 pi by 3 plus I sin 2 pi by 3. So to find the principal value, see here we took only cos theta. Instead of cos theta, if we take sin theta also, we get the same thing. For example, sin theta in quadrant 1, sin theta is root 3 by 2. Sin of which angle is root 3 by 2? Sin 60 is root 3 by 2. Definitely, here if it is 1 by 2, then it has to be root 3 by 2. Here 1 by 2 and here also 1 by 2 we will never get. Because the angle value will be same. This for the same angle, this values will be different, right? So here it is 1 by 2, this will be definitely root 3 by 2. So you can, even if you are taking sin theta root 3 by 2, we know that 60, sin 60 is root 3 by 2, again 5 by 3. For locating this position, we take the x and y axis, x and y coordinate, sin of x and y coordinate. Again, one more thing we wrote. To locate the position, either we take sin of x and y coordinates, this is x and y, or one more thing we said, what? Sin, okay, one doubt. The doubt is, so for sin theta, the value of theta y you took it as positive. Not only for sin theta, even for cos theta also, cos alpha you took it as positive. Why did I take positive? See that notes. In bracket it is given in quadrant 1. For finding alpha in quadrant 1, we take always the positive value to get alpha in quadrant 1. Once after getting alpha, then only we get the position of our theta. The position of our theta. That means the position of our principal value. To find the position of principal value, we suggested two methods. First method is by seeing the sign of x and y. That is what we do here. X and y. Second method, one more method we suggested. What's the other method? The other method is or by seeing the sign of sine and cos. Sine and cos. We learned it in trigonometry. All positive, sine, tan, cos. All students take coffee. All students take coffee. In trigonometry, we wrote it in notes. Either by seeing the sign of x and y, that is what we use here, that method we use here. Second method is or by seeing the sign of sine and cos. Here, sine is positive, sine is negative, cos is also negative. In which quadrant both sine and cos are negative? In quadrant 1, both are positive. Here, both are not negative. Here, sine is positive. Fourth one, cos is positive. So in which quadrant both are negative? Only third quadrant. Here tan is positive. That means both sine and cos are negative. So quadrant 3. So by seeing the sign of sine and cos, or by seeing the sign of x and y, we can locate the quadrant in which our principal value lies. Once when we get the quadrant, then use that table. Which table? Alpha in quadrant 1, alpha, theta is alpha. Quadrant 2, pi minus alpha. Quadrant 3, minus pi plus alpha. Quadrant 4, minus alpha. Using this one. And how do we find alpha? For finding alpha, we take the numerical value. Numerical value means take always the positive value. And positive, definitely this value will be a standard value, either 1 by 2, 1 by root 2, root 3 by 2. These are standard values. Only those standard values will be. Then we find. So here to find writing polar form, one question is 100% sure that you for 4 marks in your board paper, in all exams. So it's very easy. First x plus iy, we write the value of x and y, then modulus it, which is r root of x square plus y square. Then we write x plus iy is equal to r into cos theta plus I sin theta. X is r cos theta, y is r sin theta. Put the value of x and r, we get the value of cos theta and sin theta. After getting cos theta and sin theta, take only one of the values, either cos theta or sin theta. Take the numerical value and find alpha. After finding alpha, by checking the sign of x and y, or by checking the sign of sin and cos. Only one method. You don't know any method. Whichever is comfortable for you, go for it. Just by checking the sign, we can locate the quadrant in which our principal value lies. Once when we find the quadrant, then use that. In quadrant 1, principal value theta is alpha itself. If it is in quadrant 2, we take it as pi minus alpha. If it is in quadrant 3, we take it as minus pi plus alpha. In quadrant 4, minus alpha. That's it. So remaining questions we will do next class. So tomorrow, again, our timetable, the timing is same. Daily we have classes from 2:50 to 3:50. So any doubts, anything else? Anything else to be discussed in today's class? PTM, next PTM, forget about PTM, what PTM? So anything else? Your results will be next week. Okay, so